Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello everyone, this is a revision lesson on Unit 3, what we call it coordinate geometry. In today's lesson, we're going to observe parts of coordinate geometry, specifically what we call it the conic section. Conic section. As you know, cone is a 3D shape. When a plane intersects a cone, it forms a section. Those sections might be a circle, it might be a parabola, or it might be an ellipse or a hyperbola. In today's lesson, we're going to focus more on circles. So, if you see this conic section, these are parts of a cone. When a plane intersects, it may form a circle. This is called a circle, or it may form an ellipse, or it may going to form a parabola. So we're going to see each of them in our revision. But in today's lesson, as I mentioned before, we're going to focus more on circles. So let's try to see also other views of conic sections. Just see this three-dimensional shape. If you observe this 3D shape, a plane may intersect the 3D shape and it might form a section. So the section might be, as I mentioned before, a parabola, a circle, or an ellipse, and sometimes it is also a hyperbola. Good. So let's try to see our learning targets. We have some objectives to attain at the end of this lesson. So let me introduce you what our learning objectives are. After completing this specific topic, you may be required to identify the standard form of equations of a circle. So in geometry, as you know, there is a standard form of equation of a line. The same way, we may write standard equations of a circle. A circle we may define a circle as a set of points which are equidistant from a fixed point. This fixed point, we call it the center of the circle. And there is a line segment which starts from the center of the circle to the edge of the circle. And this line segment, we call it the radius of the circle. So if you want to draw a circle, what we do is we may just use the center of the circle, then using our compass, and by making this a center and by using a fixed distance, we can easily draw the circle. So this circle has center and also it has the radius. So this is the radius of the circle and this is the center of the circle. We may call the center of the circle as HK, or you might represent it as AB, or using any other variable. Then we may represent the standard form of equation of a circle is x minus h the whole square plus y minus k the whole square is equal to radius square. This is derived from the distance formula. So you will be required to identify the standard form of equation of a circle at the end of the lesson. And you may also be required to rewrite equations of a circle. We may have equations of a circle using what we call it the completing the square root method. You may be required to rewrite the equation of a given circle. Some circle vocabulary. As I mentioned before, I showed you the center of a circle, Then using the center, we may draw. Good. So let's just take this is the center of the circle. Then using a fixed length, the radius, then you may draw a circle of radius r. And this center, we may represent it using the variable hk, h comma k. Then we have those important vocabularies, what we call it the radius and the center of the given circle. So this is from conic section. A section is an intersection of a plane with three-dimensional figure. So this is also an important terminology under this topic. And you may have what we call it conic section. Conic section is the intersection of a plane with a cone. And again, circle. Circle is a set of points which are equidistant from a fixed point. And this fixed point, we call it the radius of the circle. Good. Okay. Again, as I mentioned before, radius is the distance from the center of a circle, or sometimes we may consider also a sphere until the edge of the circle. As I showed you before, this is the center of the circle, then this is the radius of the circle. And twice of the radius, we call it the diameter. So this length is the diameter of the circle. Sometimes in writing equation of a circle, you might be required to find the diameter of a circle. At the same time, you may be required to find the radius of the circle by writing the equations in a standard form. We already defined what a circle is. This is how it is forming from conic sections. So it is the set of points that are the same distance from the center. And the center, sometimes we may represent it, as I mentioned before, using the variable hk. And this is the standard equation of a circle. A circle may be represented using this form. As I mentioned before, this is derived from the distance formula. So x minus h, the whole square, plus y minus k, the whole square, is equal to r square, where h and k are the center of the circle, and r is the radius of the circle. So if you observe, this is a circle. This is a fixed point called the center of the circle. So every point are equidistant from the center. And this length is the radius of the circle. So the center is hk and the radius is r. If I have this equation, let me say x minus 2 the whole square plus y minus 3 the whole square is equal to 9. If you are asked to find the center and the radius of the circle, what we are going to do is, this is h, and you may represent this as k. And we mentioned here r is a square root. So 9 may be rewritten as 3 square. So the radius is going to be 3. So the circle has the center, which is 2, 3, and the radius, which is 3. And sometimes if you are asked to find the diameter of the circle, what we do is you just double 3 or multiply it by 2, then it gives you 6. This is how equation of a circle, which is written in standard form. So, as I mentioned before, we can determine the equation for a circle by using the distance formula, then applying the standard form of the equation. Good. The standard form of a circle with center at 0, 0. So in this case, if we try to consider the coordinate plane, if the center of the circle is the origin, which is 0, 0, the coordinate of the origin is 0, 0. And if we have a certain radius, let's call this one is r. If we know the center, we may rewrite the equation as x minus h the whole square plus y minus k the whole square is equal to r square. So we have the center, which is 0, 0. Then we have x minus 0 the whole square plus y minus 0 the whole square is equal to r square, where r is an element of real number. So here it's going to be x square. X minus 0 is just x, so we're left with x square plus y square is equal to r square. So we may going to form a circle of radius r, and the center is at the origin. Okay, x square plus y square is equal to r square. This is the standard form of equation of a circle, center at the origin, and the radius is just r. Okay, so the center, now let's try to write an equation of a circle with center 0, 0 and radius 2, just applying this formula. And if you see the diagram, it looks like this. So the radius is 2 and the center is 0, 0. So the equation of the circle will be x square plus y square is equal to 4. 2 square is just 4. Okay, if I just give you this as an example, this is the standard form of equation of a given circle. We are required to find the center and also the radius. So this, you may represent it as h, which is the x coordinate of the center. We may rewrite this as y minus 8 the whole square. Before we mentioned the standard form of equation of a circle is x minus h the whole square plus y minus k the whole square is equal to r square. So in order to get this form, we may rewrite it as, this is a plus sign, we may rewrite it as y minus 8. So in this case, k is going to be negative 8. So this is the value of k. So r square is 81. In order to find what r is, we just square root it. So the center hk, which is 2, negative 8, and the radius is the square root of 81, which is 9. So let's see example 2. This is given to us. We are required to find the center and also the radius. So we may rewrite this as x minus 0 the whole square plus y minus 1 the whole square is equal to 1 square. 1 square is just 1. So the center of this circle would be 0, minus 1, and the radius would be positive 1. So the center is 0, minus 1, and the radius is positive 1. Exercise, it says calculate the center. So we are required to find the coordinate of the center and the radius of the following circles, if applicable. Sometimes it is not possible to find the radius. For example, if I have square root of, let's say, minus 5. In the set of real number, this is not defined. In that case, we may say it is not applicable or it is not the equation of a circle. So let's see this example. So this says x square plus y square plus 14x minus 8y is equal to 56. What makes it different from the previous example is that this is not written in a standard form. So we are required to write this equation in a standard form. Maybe we may use completing the square method. So if I rewrite this equation as x square, okay, if I collect all the x's together, plus 14x, then all the y's together, plus y square, then minus 8y. Let's subtract 56 on both sides. So this would be negative 56. So negative 56. So my new equation is x squared plus 14x, y squared minus 8y is equal to minus 56. The purpose of doing this is that in order to complete the square root and find the coordinate of the center. So here, if you observe, the coefficient of x is 14. So when we use completing the square root method, we divide 14 by 2, which is 7. Then let's try to square this, 7 squared, which is 49. So my new equation would be now x squared plus 14x, then add 49 on this side. Since I added 49 on this side, I should also add 49 on the other side, plus 49. And again, I do the same thing for y. So this is plus y squared. If I divide minus 8 by 2, so let's divide minus 8 by 2. That gives minus 4. Then square it. Minus 4 square. Do not forget bracket when you square. So this gives you 16. So let me add 16 on this side. Minus 8y plus 16. Since I added 16 on this side, I should also add 16 on the other side. So this will give you, if you just observe this equation, will give you x plus 7 the whole square. And again, if you observe this, it will give you y minus 4 the whole square is equal to, let's try to simplify the other side. Then that will give us the value of the radius. So let's try to see the solution together. So we already got x plus 7 the whole square, y minus 4 the whole square. If you try to simplify this number, minus 56 plus 49 plus 16, it gives you 9. So our equation becomes, now we rewrite it in standard form. So the equation becomes x plus 7 the whole square plus y minus 4 the whole square is equal to 9. So using the standard form, with the help of completing the square root method, we easily found the center of the circle and also the radius. So the radius, in order to find the radius of the circle, we have to square root 9, then that gives us 3. So the center of the circle is minus 7, positive 4, and the radius is positive 3. So this is the solution. So once, if you rewrite the given equation in standard form, you can easily find the radius and also the center of the circle. So let's try to see exercise 2. This is given, again, this is not written in standard form. So what is expected from us is that we have to rewrite it in a standard form first. So if you observe here, the coefficient of x is 9. Also the coefficient of y is 9. So the coefficient of x squared and y squared should be 1. And for that reason, what we do is divide by 9. Let's divide both sides by 9. So if we divide both sides by 9, our new equation becomes x squared. 9x squared divided by 9 is x squared. And 9y squared divided by 9 is, again, y squared. Then minus 6 over 9. We will simplify it later. Minus 6 over 9x. Then let's divide 36 by 9. Then we'll get minus 4y. Then let's again divide 107 by 9. Since it's going to give us a decimal, let me just leave it as a fraction. Then is equal to 0. 0 divided by 9 is just 0. Then our next step is collecting all the x's together. So we'll have x squared minus, if we try to simplify 6 over 9, divide both sides by the same number, which is 3, then we will get minus 2 over 3x. So this simplified as 2 over 3x. Then plus y squared, then minus 4y. Let me try to add 107 over 9 on both sides. So my new equation becomes 107 over 9 on the other side. When I add 107 over 9 on both sides, this will cancel out, and I left with 107 over 9 on the other side. So now let me take this coefficient, minus 2 over 3. So divide minus 2 over 3 by 2. I'm going to use completing the square root method. Let's divide this by 2. Divide this by 2. Meaning, we may multiply this by 1 over 2. Then this 2 will cancel out, and we get minus 1 over 3. Then let's square this. Minus 1 over 3, square it. Then do not forget again bracket here. So it just gives you 1 over 9. So this becomes now x squared minus 2 over 3x plus 1 over 9. This is an expression for x. And again, let's divide minus 4 by 2. I am still using completing the square root method for y. Minus 4, divide this by 2, which gives you negative 2. Then square this. Square this. It gives you positive 4. Then this expression becomes plus y squared minus 4y plus 4 equals 107 over 9. Here, I added 1 over 9 on this side. So I should do the same thing on the other side, plus 1 over 9. I also added positive 4 on this side. So I should do the same thing, which is plus 4. So this is our new equation. This is group of y's, and here we have x's. This expression may be simplified as x minus, here we divide minus 2 over 3 by 2, and we got negative 1 over 3. So we have minus 1 over 3, the whole square. And again, we have this expression. We divided minus 4 by 2, which is negative 2. Then this becomes y minus 2, the whole square. Then let's try to simplify the other side of the equation. So if we add 107 over 9 plus 1 over 9, since they have the same denominator, we get 108 over 9 plus 4. So let's further simplify it. So we have x minus 1 over 3, the whole square, plus y minus 2, the whole square. 108 over 9 is 12. Then 12 plus 4 is 16. So we have that equation. This is a standard form of equation of a circle. So you may represent this as h. This is our h. And again, you may represent this as k. And to find the radius, this is r square. This one is just r square. Then to find the radius, we square root 16. Square root of 16, which is just 4. So the center of this circle would be 1 over 3, comma, positive 2. The solution is here, and our final answer is x minus 1 over 3 the whole square plus y minus 2 the whole square is equal to 16. As I mentioned before, the radius is clearly written, and also the center of the circle. So the radius is the square root of 16, which is 4, and the center is 1 over 3, comma, positive 2. Good. This is a solution of this exercise. Now, we said a circle is a set of points which are equidistant from a fixed point, which is the center of the circle. Okay, so this is the center, and that's the radius of the circle. So you may have also a line this line. We may represent this as L. The standard form of equation of a line is ax plus by plus c is equal to 0. If you just observe a circle and a line, we may just categorize their relationship in 3 different categories. The first one, the circle and the line may not intersect at all. So the circle is here, the line is there, so there is no intersection point. And the other relation is a circle and a line may intersect at 2 points. So this is the point of intersection between the line and our circle with center HK and radius R. So this line, we call it the secant line. If a line intersects a circle at exactly 2 points, we call it a secant line. And the other case is, you may have a circle and a line, and they may intersect at exactly 1 point. So in that case, we call it the tangent line. And this point, we call it point of tangency. So the radius is here. So the angle between the radius and the tangent line is 90 degrees, which means the radius and the tangent line are perpendicular. So once if we know the gradient of the tangent line, or once if we know the gradient or the slope of the radius, we can easily find the slope of the tangent line. Good. So they intersect at right angle, which is 90 degrees. So if we want to find now if equation of a line is given to us, and if we have also a circle with center HK, we may be required to find the distance between the circle and the line. So we may use this formula. D equals absolute value of A times H, where A is this constant, the coefficient of X. B times H is the X coordinate of the center. And B times K. B is the coefficient of Y. And again, K is the Y coordinate of the center, plus the constant C, divided by the square root of A squared plus B squared. So again, we have 3 different relationships in this case. Your distance, or D, may be less than the radius. In that case, we have the secant line, which is this one. And again, our distance, or D, is greater than the radius. In such case, the line and the circle do not intersect at all. And sometimes the distance and the value of the radius is the same. D is equal to R. In that case, the line is tangent to the circle. So those are 3 relationships between a given line and a circle. And you can easily just see their relationship, whether they intersect at 2 points, or whether they do not intersect at all, or to check whether the line intersects the circle at exactly 1 point, we may just use this formula. Good. So this example given, x squared plus y squared minus 2x plus 2y minus 23 is equal to 0. So now we are required to find the center and the radius of the circle. As we did before, what we do is let's collect all the x's together. We have x squared minus 2x, then we have plus y squared plus 2y. If I add 23 on both sides, add 23 on this side. So my new equation becomes is equal to 23. This will cancel out. Then now, as I did before, let me try to use completing the square root method. Minus 2, divide it by 2, which is minus 1. Then square minus 1, which gives you positive 1. Then my new equation becomes now x squared minus 2x, add 1, plus y squared plus 2y. Again, let's divide 2 by 2. 2 divided by 2, which is positive 1. Then square it, 1 squared, which is 1. Then let me add 1 here, plus 1 equals 23. Since I added 1 here, I also added 1 here. So what I do is plus 1, plus 1. Then the whole equation becomes this one. If we just try to use the standard form of equation of a circle, this becomes x minus 1 the whole square plus y plus 1 the whole square. Then let me simplify the number on the other side. 23 plus 1 gives you 25. So again, we may rewrite this as x minus 1 the whole square plus y minus of minus 1 the whole square equals 5 square. So the center of the circle becomes positive 1 and negative 1. This is the center. And the radius of the circle becomes positive 5. I think through practice, you can easily rewrite a given equation in standard form, and you can easily find the radius and the center of the circle. Good. Let's try to see the solution for A. So as we found here, the center of the circle is positive 1 minus 1, and the radius of the circle is positive 5. Good. Let's see B. We are asked to check whether the point 4, 3 is on the circle or not. If yes, if our answer is yes, we may be required to find the equation of the tangent line. If this point is on the circle, if that point is on the given circle, obviously there will be a tangent line which meets the circle at exactly 1 point. Then we can easily find the equation of this tangent line. First, let's check whether the point 4, 3 is on the circle or not. We may do it in different way. Maybe what you have to do is you may insert the numbers or substitute the numbers in the given equation. If you got a true statement, the point 4, 3 is on the circle. For example, if we use the simplified form or the standard form, if we use this equation, this is a standard form. If I try to substitute 4, 3 in this equation, okay, let me just say B. In place of x, let me replace positive 4, substitute positive 4. 4 minus 1, the whole square, plus, in place of y, just substitute positive 3. So 3 plus 1, the whole square. So let's try to find the value of this. 4 minus 1 is 3, 3 square is 9, plus 3 plus 1 is 4, 4 square is 16, then add it, which gives you 25, which is the same as 5 square. And 5 is the radius, r is equal to 5. That indicates, or that implies, the point 4, 3 is on the circle. This is one way of solving whether this point is on the circle or not. The other way of solving this, we may use distance formula. So using distance formula, we can solve this equation. Let me just show you how to solve using distance formula. So we know the distance formula, x1 minus x to the whole square plus y1 minus y to the whole square under square root. This is distance formula. We call it the distance formula. So using this method, we can easily find. We already know that the point was given, which is 4, 3. And we already solved it in B. The center is 1, negative 1. Then if I take those 2 points and replace it in the distance formula, we can easily observe that the value of this calculation is positive 5, which means it is equivalent to, or it is the same as the radius of the circle. That indicates the point is on the circle. It says, is the point 4, 3 on the circle? If yes, write the equation of the tangent line. We checked that the point is on the circle. So if the point is on the circle, then we can easily find the equation of the tangent line. So in order to find the equation of the tangent line, what we have to do is we have the point, let's say it's an arbitrary point 4, 3. This is not the exact location of the point. The center is 1, -1, and the point is 4, 3. So using this point, let's try to find the gradient of the line, meaning the slope of the line. So here we have the circle. The center is 1, -1, and the other point is 4, 3. As I mentioned before, this is not the exact location of the point. Then in order to find the slope of the line or the gradient of the line, we may say m is equal to y2 minus y1 over x2 minus x1. So applying that formula, 3 minus -1 over 4 minus 1. So this is the gradient of this line, the gradient of this line. So we know that there is a tangent line which passes through this given point. And we mentioned before the radius of a circle and the tangent line are perpendicular, which means the angle between them is 90 degrees. If they are perpendicular, we know from geometry, if two lines are perpendicular, the product of their slope, let's say the slope of the radius is m1 and the slope of the tangent line is m2, their product is -1. We already know the gradient of the tangent line, which I mean the gradient of the radius, the line which passes through the center, 4/3. Then to find the slope of the tangent line, what we do is we may use this calculation, or simply once if you know the gradient of one of the line, to find the slope or the gradient of the other line, what you do is just find the reciprocal of this number, then multiply it by -1. So the reciprocal of 4/3 is 3/4. Then multiply it by -1. So the gradient of the tangent line, this line, m of the tangent line is -3/4. If you want, you may use also this calculation. It still gives you the same answer, -3/4. So that's the gradient of the tangent line. Once if we know the gradient of the tangent line, using this formula, y minus y1 over x minus x1 is equal to m. So here, our point, the point x1 and y1 are +4, 3. So in place of y1, we just replace +3, y minus 3. And in place of x1, we just replace +4, x minus 4. We already mentioned the gradient is -3/4 equals -3/4. Then if you simplify this equation, you will get this standard form. So this is the equation of the tangent line in standard form. You may rewrite this sometimes in slope-intercept form, depending on the question. So you can rearrange this equation. So we may say the equation of the tangent line is 3x plus 4y minus 24 is equal to 0. Question C. Find the intersection point of the circle with the line x is equal to 4. So we have a line x is equal to 4, and we have the given circle. Then we are required to find the point of intersection, the intersection point of the circle with the line x is equal to 4. So the x coordinate is already given. So we have to find the y coordinate. So for that, let's try to see our solution for C. Here, this was the standard form of the circle, which is x minus 1 the whole square plus y plus 1 the whole square is equal to 25. This was the equation we found before. So we know the value of x, which is +4. So in place of x, just replace +4. 4 minus 1 the whole square plus y plus 1 the whole square is equal to 25. So our aim here is to find the value of y. So if you simplify that, it gives you 9. Y plus 1 the whole square is equal to 25. Then subtract 9 on both sides. Then you will get y plus 1 the whole square. Y plus 1 the whole square is equal to 16. In this case, what you have to do is just square root. Do not forget to just write this y plus 1 the whole square is equal to plus or minus square root of 16. So there are two possible values for y. So this will give you y plus 1 is equal to plus or minus positive 4. So we have that equation. Then let's try to make y the subject. Then y is positive 3 or y is negative 5, which means we have these two equations, y plus 1 is equal to positive 4, or the other equation, y plus 1 is equal to negative 4. So if you solve for y, or if you make y the subject, your answer will be y is equal to 3 or y is equal to minus 5. Hence, the intersection point of the line, x is equal to 4 is positive 4, positive 3, or 4, comma, negative 5. This is how to solve C. Good. So this is the end of our today's lesson. Hopefully you get some good ideas on equation of a circle. And in this topic, what we observed is finding standard form of equation of a circle, finding the radius, finding the center of a circle. Also using the completing the square root method, we just try to find the center and the radius of a circle. And again, we try to observe the relation between a line and a circle. Hopefully this lesson helps you a lot. In our next lesson, we will try to see what a parabola is and equation of a parabola. For today, thanks a lot.